So yesterday we started that whole talk with those inverse functions, and we looked at like more than one function to see if they were inverses of each other, or then we just wanted to find the inverse of a function that they gave us, right? Not too bad. So today we're going to continue with our inverse discussion, but today we're going to kind of finding the inverse, but then also kind of like looking at our domain, our x values, to see which x values fit within our parameters, or if there's any restrictions and all that kind of good stuff, right? Make sure we have our mask on, please. And have our mask on properly, please. They know you're fine, thank you. I know. All right. So we're just going to call it 1.8, and if you want, you can put the B on there, or you can just continue from yesterday's notes. So it's still on those inverse functions. So yes, excuse me. So like yesterday, we just like found the inverse, and we kind of told you a little bit yesterday, like sometimes when you find the inverse, sometimes it is a function and sometimes it is not a function. So that's part of it today, is looking at our inverse and actually determining if it is a function or not. There's a little test we can put to it, or we can find out, we can actually find the inverse and then try and graph the inverse or look at it to see if it's going to give us a function. And then talking about those domains, right? So like yesterday, you know, part of the question was, does the function have an inverse? So does the function have an inverse? And we were really good at always finding the inverse, but we don't want to know if it's just an inverse. We actually want to know if it's an inverse function. Oops, run out a little room, throw my little question mark up there, right? So the big part about this question is finding out if it's a function or not. So yesterday, I don't know, we could have had, let's say, f of x equals x squared, right? Our nice little parabola, if we were to graph this little guy out. The vertex would be 0, 0, and it's opening up, and it's just the nice little parent function of a quadratic, right? And yesterday we found out how to find the inverse of these guys. Okay, we rewrote it with x's and y's, so y equals x squared. To find the inverse, we switch the x's and y's. Okay. And then we had to solve it for y. So we would technically take the square root of both sides, and so we'd get y equals the square root of x. Okay. And technically the positive and the negative square root of x, right? If I were to take the square root of 4, what's the answer to the square root of 4? 2 and negative 2, right? Because negative 2 times negative 2 is going to give you that positive 4. So it's technically the positive and the negative square root of x. If we were to graph this, anybody know what it would look like if we graphed x squared plus or minus x squared? It's actually kind of neat. X squared, the positive, is up here, right? And the negative, x squared, is down here. Whoops, perfectly drawn, because I'm a perfect drawer. I'm an artiste in the making. I am not. I think they're getting worse, so I'm just going to stop. Right? I'm just going to make the arrows cute, or bigger, something, right? So if we're talking about functions, we started off with our quadratic. And was our quadratic a function? Yes. And there's a little line test we can use in order to test that. Does anybody remember what that little line test is called? Remember the vertical line test? Right? So that vertical line test tells us that x squared is a function. Now that we have our inverse drawn, which was our green, right? Is that a function? Nope, because when we do that vertical line test, guess what happens? We cross it more than once, right? So our function that we started with is a function, but when we found our inverse is not a function. And if we wanted to write that as function notation, would that be f, the inverse equals plus or minus the square root of x? If we wanted to get fancy from yesterday. So one way to answer this question is you can start with the original. You can go through and find the inverse and then graph it, and then go ahead and do that vertical line test to see if it's a function or not. But guess what? There's another way. So a mathematician sat there and discovered this little thing. Instead of the vertical horizontal test, they came up with a horizontal line test. Don't ask me why I'm putting so many squares and lines over it, right? So what the horizontal line test tells us, if we go back up to this original graph that we had, and we originally graphed y equals x squared, because that was our original, right? So it's a function because it passes that vertical line test. But to find out if its inverse is a function, we can actually do this horizontal test. And when we do the horizontal test, guess what happens? Does it pass or does it fail? It fails the horizontal test. And because it fails the horizontal test, we know that when we found our inverse is not a function. When you switch the x's and y's, you're reflecting your graphs, and you're reflecting them over that identity line, which is where that goes right through here, that identity line. That identity line is when y equals x, right? Because that's exactly what we did. We took our y, and what did we make it equal? We made it equal our x, right? We took our x, we made it equal our y. So when you do the inverse and you switch those, you're reflecting it over that line y equals x. So that's how you can do. So if I took my y equals x squared, and if I reflect it over that line, that's going to give me my inverse. So to test the horizontal line test, we start with the original function that they give us. So let's say we had a cute little graph. Okay. And I don't know, let's go with a line. Okay. And this is my f of x, my original, not my inverse, just the original function. And if I want to put the horizontal line test to it, I'm drawing all these horizontal lines, and every time I draw a horizontal line, I'm only crossing it once. So that tells me that this has an inverse function. We know it has an inverse because we can always find the inverse. We're just trying to see if it's a function or not. Okay. What if we had something, we had our little x and y, and we had an upside down parabola, right? And this is our original, or f of x. And we want to know if the inverse is a function. So what do we apply to it? The horizontal line test. It fails the horizontal line test. So we still know we can find the inverse, but the inverse is not a function. So there's no inverse function. Okay? It's not one-to-one. Want to try one more? I'll go a little squiggly. Woo! That one looks like fun, doesn't it? Right? We know it's a function because it passes the vertical line test. Right? Oh, so we knew this was our function. So we want to know if the inverse is a function. So we're going to try that horizontal line test. Oh, I hit it once there. But when I go down here, man, 1, 2, 3, I hit it 3 times. So now I know that its inverse is not a function. The inverse is not a function. Poor guy. Right? We might want to graph. We love to graph things, don't we? We love our x and y coordinate plane, right? So we can even use graphs to find inverses. So I'm going to make a decent sized little Cartesian coordinate plane. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I have dot paper on here. I should use dot paper. Probably be a little straighter, right? So when they give you guys these problems in the textbook, because it's nice and pretty printed, like they're not going to give you the coordinate points, so you just got to look at the graph and find the coordinate points. So I'm going to kind of cheat a little bit, and we're going to make some coordinate points so that we're all on the same page and ours all look nice and fresh, right? So let's go with like -3, 0 is a point. We'll throw that on here, -3, 0, right? This is my original, so this is my f of x. I don't know, let's go 1, what do you want, 1, 1, 3? Is that a good one? Oh, -1, 3. How about 1, -2? Oh, let's go 3, 3, 5. 1, 2, 3, 4, 5. And how about I don't know, -5, -5, -4? Just to make things nice and spicy. Or no, sorry, not -5. Let's go +5. I apologize. Let's go +5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Just trying to change it up a little bit for you guys. Now we're just going to connect these. Okay. Make your dots a little bigger if you need to. It's what I do sometimes. And we know this is a function because it passes the vertical line test. Before we go any further, do you think the inverse is going to be a function? No, right, because, good job, yep, absolutely. It fails that vertical line test. But even though it's not a function, we can still find the inverse, right? So if I want to switch this over to the inverse, so little inverse notation, what do? I just switch my x and y's, right? So I now have 0, -3, 3, -1, -2, 1, 5, 3, and -4, 5. So let's plot all of those points. So sometimes if you had different colored pencils, pens, markers, helps a little bit. So I have a 0, -3, 1, 2, 3, -1, -2, 1. And you can sing the points too, it helps a little bit. 1, 2, 3, 4, 5, 5, 3, 1, 2, 3. And -4, 1, 2, 3, 4, 5. There we go. Oh. Look at that. Hey. Let me tell you, like, if I were to lay down right now, I think I would like fall asleep in like 30 seconds. Like, just one of those days, one of those weeks. Too many things going on in my head. So you get a nice, beautiful graph like this. Thank you for your help. I appreciate it. It's not like I just didn't do this last hour. All right. The other little question that you guys will ask you is about those domain restrictions. So we've been really hammering on the domain and those domain restrictions. Okay. Domain are our x values, right? So we know like we can't have zeros in the denominator, those types of things, right? So ultimately, if you go and you figure out your inverse and say your inverse comes out to be 1 over x plus 2, we have a domain restriction, right? So we still can have functions and all that good stuff, but it still has a restriction in there. And like on this one, we know that we have that restriction to where x cannot equal -2, right? So they just want you to make sure that you're still being aware of those restrictions when those come out. Another example would be, let's say you started off with f of x equals x squared minus 1, right? So that would be y equals x squared minus 1. To find the inverse, we're going to switch those x's and y's. So x equals y squared minus 1. We got to get y by itself, so we're going to add 1 to both sides. And then we're going to take the square root. So now we're going to have the square root of x plus 1 equals y. But when it comes to radicals, what do we know about radicals? Because we're looking in the real world, right? We're not being all imaginary. We're not in Alice in Wonderland. We know that we can't have negative numbers for square roots, right? Those are those imaginary numbers. And we're just focusing on real numbers. So we have to make sure that the part under our radical sign is greater than or equal to 0, right? So when it comes to that restriction, or we can even just say for our domain, right? We know that the part under the radical, x plus 1, that has to be positive or 0, so it's got to be greater than or equal to 0. So what do we know? X has to be greater than or equal to -1. So our inverse is that square root of x plus 1, but we also know that x has to be greater than or equal to -1. Right? So I know like in Algebra 2 we kind of always touched on a little bit when it comes to, or actually all the way through math, where your denominators can't be 0. And we kind of pushed a little bit on Algebra 2, but now they really want you to make sure that you're focusing and looking at that problem as a whole when you get done and asking yourself that question. Are there any values that I cannot use? Is there any any restrictions on my domain.